Hi everyone! Today I will be giving a brief tutorial about how to use the DESops package within Python. For some context, I will be operating on a MacBook Air and I will be using VS Code as my IDE. Additionally, it is important to note that I already have DESops installed within my virtual environment, but there will be an additional video that goes in depth about the installation process. But for now, this tutorial is going to focus on basic features within DESops, such as constructing automata. Let's begin. So as you can see on line 1, I imported this package by writing import DESops as D. Whenever we're scripting, it's really important to assign the package as a certain variable name because this will be how I access certain features within DESops. So the first feature I'm going to show is how to build an automaton. And when we do this, we first initialize it as a variable name. In this example, we're going to use E. And to build an NFA, I'm going to say d.nfa. And if I wanted to use a DFA, I would say d.dfa. But for now, we're going to stick with NFA. The variable E will have access to all NFA-related functions. And so I always like to start off with adding vertices. So I'm going to use e.add_vertices and specify the number of vertices I wish to add. And I'm going to print out and show what this looks like. So in my terminal, we will now see a list of 5 vertices that are each assigned an index starting at 0, and there are no edges or transitions coming out of them, and those are those empty lists we see to the right. So one thing I want to make clear is when we first initialize vertices, they're given a specific index, and that will by default be their name as well, but we can actually alter the name by using e.vs. E.vs will give you access to all vertices within that specific automaton, which is super helpful whenever you want to edit a certain attribute of a vertex, or if you wish to iterate through all the states in a specific automaton. So in this case, E. Just a quick side note, if I wanted to access specific edges, I would use e.es, and this basically does everything that e.vs does, but except for edges. But for now, I will just be focusing on e.vs for this example since we don't have any edges yet. So now I'm going to show you how to change the names of the vertices. I'm going to use e.vs in the attribute name, and I'm going to create a list that is the same length as the number of vertices, and I'm going to write which names I wish to rename each of the states. And once I'm done with this, I'm going to print out E, and in my terminal, we're going to see that they are renamed. And one thing I want to make clear is although we changed the name, the vertex index is unchanged. And to show this, I'm going to print e.vs0 name, and we should get A. And this means the vertex with index 0 is assigned a name A. Since we created vertices, the next step is usually to add edges. And E has a built-in function called add_edges that can help us complete this. First, I'm going to create a list of tuples where the first coordinate is going to be the starting state and the second coordinate is going to be the ending state. In this function, as well as many other functions throughout DESops, we are going to label vertices based on their index and not their name. So when I write 0 to 1, I'm talking about the vertex at index 0 going to the vertex at index 1. In the first half of this function, I have now defined 5 edges that have a given start state and an end state. Now the next step is to label them. I'm now creating a list that has the same length as the first list I made, and I'm going to label each respective transition. So A corresponds with 0, 1, B corresponds with 1, 2, etc. And once I print this, we are now going to see that these edges now appear within each respective state. In the terminal, it shows the destination and the label of that edge. To further visualize this, I'm going to show a feature called plot, which is incorporated within iGraph. And this gives a really great visual representation of the automata. So if I use d.plot_e, I will now see an image that shows each of the states, their names, the edges, and their labels. So this is very helpful, especially when you're debugging. In this next section of the tutorial, I'm going to be discussing how to read files and what kind of file formats we typically use when constructing automata. What I'm going to do now is initialize a new automaton. It's going to be the exact same one as E, except this one I'm going to read from an FSM file. So I'm going to call this F and read it using d.read_FSM and then the file name. Make sure you're in the same working directory as this file to avoid any error messages. I think it will be helpful to show what an FSM file looks like and how it is formatted. So here's an example. This is the exact same automaton we created in E. The first line will always show the number of states that are currently present, and then each section will go in order of the indices. So this first part is index 0. On the first line for each vertex, the first column will always be the name of the current vertex. The second column is a Boolean value, 0 if it is unmarked, 1 if it is marked, and the third column is the number of transitions. So this one has 1 transition. On the second line, it has the event label, followed by the target state name, and then C if it's controllable, UC if it's uncontrollable, O if it's observable, and UO if it's unobservable. And this repeats for as many vertices that are present. So the next section will go for vertex 1, vertex 2, etc. As I mentioned, this is the exact same automaton as E, and to show this, I'm going to plot both of them. So I'm going to write d.plot E as well as d.plot F. And once I plot these at the same time, we're going to see a side-by-side viewing of both of them. And it is now clear that these are identical. They have the same state names, the number of states, edges, and edge labels. And this concludes this tutorial. Once again, this was just to give an idea of some basic functions incorporated within DESops. There will be more videos in the future that go more in depth about specific operations, as well as the installation process of this package. And once those are uploaded, they will be linked down below.